Welcome to Math 104, where we're talking about quadratic regressions with Desmos. We're also going to be doing the average error on here as well at the very end. So the problem on this one says the data shows the percent of people in the world who are internet users from 2014 to 2025. Find a quadratic function that models this data with representing the years after 2010. Report with 3 significant figures. Find the number of years it takes for the model to reach 57% of internet users. Use the model to predict the percent of internet users in 2023. So first off, we are going to open up Desmos. We're going to click on the top corner with the plus sign. Now, when you can, definitely make an account with them. It's free. That way you can start to save your regressions, because when we come to the quadratic or the project, it might be nice for you to have everything laid out all in one. So up here, we're going to click on the table, and then we're going to enter in your X values. Now, keep in mind, it does tell us that X is the number of years after 2010, which means we have to change all of these values to represent those that follow after. So if X is equal to 0 for the year 2010, then what does that mean for the year 2014? Well, we can take 2014 minus 2010, and that will equal when X is equal to 4. So that is just the difference between those two values. I'll scoot that over so you can see a little bit better. And then we're going to do that for each and every term that you see here. So we're going to enter that in. So we're starting our data at 4. Then 2015 would be 5, 2016, 6, and 7. And so you're going to notice that as we're going through, you can start to enter your data. It'll just pop up for you. The only thing with this is that notice that it goes from the year 2020 and it jumps to 2025. Our computer doesn't know that we're going to do that. So instead of 11, we're going to have to put in 15. So be super careful. While it is a nice feature, it does allow us to make a mistake, a very easy mistake. So just double check that these are correct, and then we're going to go ahead and enter in your Y values. And you'll notice that some of these are going to be popping up to the left, or at times it does. We're going to have to adjust our data, our window. So once you enter in everything, just go ahead and double check that all of this matches with what we're provided. Okay, all right, we're good. So these are our actual values that we are given. And what we're going to do is generate a function. Now, before we know what function to do, we actually have to take a look at your graph. Now, notice here, none of your graph is coming up. That is because your X values and your Y values might not work. So using that little tool over here, we're going to see that your X values span from -10 to 10, while our values go from 4 to 15. So while some of these will fit in this range, not all of them. So notice that 15 is going to get cut off. And also notice that our X values do not go so far in the negative. So perhaps this time around, we're getting as close to 4 as we can without cutting off the value. So I'm going to say, let's start at 0. We're going to tick all the way up past 15. So maybe past 15 is 25. You can change the scale if you want. There's not a whole lot of distance between 0 and 25. If you wanted to go up by 2s, 3s, or 4s, that's okay, not by 23. So you notice that by changing the step, it just tells you how far between. If you wanted to get rid of the minor grid lines, maybe it's too hectic for you, you can switch that off. Now look at your Y values. This is creating a huge issue. Our Y values, the smallest one that we can see is 41.1, and we go all the way up to 61. Ours are definitely being missed. So we're going to get closer to these values. So if we're starting at 41.1, perhaps we start ours at 30. And ours go all the way up to 61. So maybe we go to 70, right? So now we can definitely see that curve aspect. And if I click out of this, you'll notice that there is some dead space over here. We don't quite need it, but it might come in handy. So it's up to you whether or not we want to get rid of that. So taking a look at your data, does it look linear, quadratic, cubic, logistic, any function that we have seen before? Now it doesn't exactly look linear. Some of the first few could, but you'll notice that it's going to start to curve just ever so slightly. So what we're asked to do is to actually generate a quadratic function. So your quadratic function is going to have this particular equation where we have y sub 1, and to hit the sub 1, we're going to hit the shift button or hold it down, and then we're going to hit the dash symbol. And then to get the very next symbol, we are going to be holding down your shift key and clicking right up here to the top left. Then we have ax sub 1. Oh, and notice that you just have to click out by hitting the right arrow. So let's do that again. Ax sub 1. Now this x value is squared, so hitting the shift key and then the caret. So I'll show you that. The shift you're going to hold down, and then you're going to hit 6. And then plus the x sub 1 plus c. Now we need the x sub 1 and the y sub 1 to refer back to our table. So before we interpret your equation, let's go ahead and look at your graph. What do you think your line against your points? Do we like it? Do we hate it? Well, we should really be in love with it. Just about all of your points are hitting that line. Not exactly. You'll notice that there is a little bit of a missed error between definitely 3, 4 of them, but they are very good. I would say this one is an excellent fit. So that being said, what do we think your correlation coefficient could be? Keep in mind your correlation coefficient is determining your strength. So it should be very, very close to positive or negative 1. Now let's go ahead and let's type in your regression before we get to what happens if we don't have your R. Switch that over. So if we have y equals, and we're just following the format of ax squared, so a being 0 or negative 0.092, and we'll talk about rounding here in a moment, 0.092. We have x squared plus 3.527 x plus 28.755. So we'll just kind of leave it there for now. We'll talk about rounding here in a moment, but that kind of gives you a gist of your equation before we get into the nitty-gritty. So now let's take a look at r squared. When we go to do our project, we actually need your r, not your r squared. So if you are given your r squared, we're actually going to be taking the square root of this value. It's going to be more useful to us. So we're going to go over to your Desmos scientific calculator, and we are going to take that value, which I forgot to record it, 9992. So we're going to take the square root. To write a square root, you can either hit the square root down here, or you can write SQRT. 0.9992. So the square root of that value. So r is equal to 0.99959. Rounding that up, because we end on a 9, we're going to round that up to 6. Now, is this number close to positive or negative 1? Yes, it is very, very close, which is what we want to see. So that is why your graph is a really excellent fit, because it is almost at a positive 1. Now let's go ahead and answer your questions. So it says find the linear, so it should say find the quadratic model to 3 significant figures. So 3 significant figures, again, this is a very brief explanation on 3 sig figs. We are using significant figures with any sort of number that is not 0. Those are going to be considered significant no matter what. And any sort of leading 0, so you'll see the 2 zeros leading out front here, those are not significant. So when we do not end up counting those in terms of significance. So we have negative 0.0, and then 9, 2, those are our first two significant figures. And then the third one is 1. Now with your rounding, we definitely want to look to the fourth value and determine, do we keep the 1 or do we increase it? Because right next to it is 0, it's not going to change the 1 at all. So we get to just keep it. So that's x squared plus, and then looking at, again, the next 3 figures. So 3 is significant, it's a not 0. 0.5, again, significant. So that's 2, and then 2 is significant, and then we'll type the very next number. So taking a look, are we going to round to or keep 2? Well, because it's a 7, we're going to round to a 3. So there you have your 3 significant figures. Then we're going to add, and again, rounding, so pause whenever you want, to 8.75. We are going to round that 7 up because it ends on a 5 to 8. So here we have our equation with 3 significant figures. Now let's take a look what it would look like if we did it with decimal places. So 3 decimal places. Y is equal to negative 0. Now we're just looking at 3 decimals, 0, 9, 2, 1. So looking at next to the 2 is a 1, we're going to keep the 2, x squared. So look how that number looks a little different than our first term. And then plus 3 points, and again, we're rounding out to 5 to 7. And again, that one looks a little different than the one before it. And again, to 8.7551. We're rounding that out. We cannot have 4, so we're going to leave it here. So that is what it looks like if we did 3 decimal places. Now, using what we have for your equation, which we're going to be using, I believe, the 3 significant figures, we're going to take a look at what year it will get us to 57%. Now, because your y value is already as a percent, we do not need to change your y value. So because we do have a y value, however, we can enter that into your equation should we like. Now, because it is going to be a little harder to enter that value in because you have a series of x squares, well, actually, we can use your quadratic formula. I'll at least write that there. Negative 0.0921 x squared plus 3 x plus 28.8, right? We can certainly start to solve by bringing that 57 over, subtracted by the 28.8, and then use the quadratic formula. So we could do that if we wanted. So we can say subtract. So we'll have 0 on one side, negative 0.0921 x squared plus 3.53 x plus, actually it'll be minus, so let's go ahead and subtract those values to 8.2 minus 57. So that'll be negative 8.2. So from here, you can use the quadratic formula, which I believe we covered in chapter 3.2, I believe. So we can do that, or we can also take a look at your equation. So your equation being this in green. So we are looking at the y value to be 57%. And we want to get as close as we can to that 57. So notice I'm at 61. We're looking for 57%. Oh, I just went right over. Come on. And I'm not the best with Desmos. So it's going to be about 11.43 or so. And if we scoot down just a little bit, even if we're at 56.997, we're still at 11.4. So we kind of conclude that x is equal to 11.4 ish, which again, this isn't the year 11.4. It's really rounding up. We're now into your 12th year. We've completed 11 years and now we're into 12. So we have X being 12. Now, what does that mean as far as a year standpoint? Well, a yearly standpoint, right? If we start at the year 2010, we're going to add 12 to that variable, or sorry, add 12 to 2010, which gives us the year 2022. Now, this is only one destination where where y is equal to 57. So we can go ahead and try it again, but for your other side. So again, looking where y is equal to 57, and as close as we can on that one. Actually, I just recalled the easiest way to do it on here. Let's see, you can be like me and kind of adjust. Oh, I almost had it. So it's about 26.8 or so. Oh, let's go ahead and just make, if we know what y is equal to, we can hit y equals 57. What am I doing? I'm a goober. So over here, you'll notice that y is equal to 57 at about, let's see, why is this going? There we go. So here's one spot, 11.402, and again over here, 26.9 or so. So I'll write that over here. X is equal to 26.9. So about 27 years, which again, we're going to be adding to 2010. So in the year 2037, I have completely lost my head. So in the year 2037 and 2022, you will have 57% of internet users. I want to say in the US, if that was the problem. Okay. So that is if you are trying to find your y, or your, so sorry, if you have your x value and you need to find your, you have your y value, but need to find your x. So let's do the opposite. Let's predict the percent of internet users in 2023. So we don't have that year. So we really need to figure out, well, what does X signify? So the year 2023 minus 2010 will give us X being 13. Now we can enter that right into your equation here. So y is equal to negative 0.0921 x squared, or sorry, not x squared, 13 squared plus 3.53, 13 plus 28.8. So we can go ahead and write that in. Let's see, negative 0.0921, 13 squared. I like to put it as a square on the outside, plus 3.53 times 13 plus 28.8. So we have about 59.12 or 59-ish% of this occurring. So let's say y equals 59%. So if we want, we can always try to locate where that x value is. So I'm going to go ahead and hit or type in your equation with that 3 significant figures, 0.921 x squared. Actually, I wonder if that'll work. Oh, okay. No, that just copies it. So I was right. Plus 3.53x plus 28.8. So you're going to end up having the new equation that's going to be on top of the other one. But what it allows us to do is, if it allows us to hit that edit list and go to a table, well, if we know what the year that x is going to be 13, we just need to figure out, okay, well, where is 13 on your table? So it is about 59.1-ish, so 59%. So this is if you have an X but are trying to find your Y value. So you have two different ways to solve. Okay, so now let's take a look at your average error. So I'm going to go ahead and take that part away. So let's go ahead and look at your predicted values. So we are going to go right into the second cell and we're going to click this residual plot. By doing so, it allows us to pull up the difference between your actual Y values and then the predicted Y values here. Oh, and we don't really need those plotted, so I'm just going to take that away. This is just the extra plot that I put on there, which I can just take out. There we go. So now that you click that button, we're going to go ahead and enter this formula over here, making sure that nothing is changed. So what I mean by that is do not capitalize anything that it isn't already. So total, and then E sub 1 all squared. So this is your error. So this is the difference between the Y values. So really taking this and summing them all up. So we're going to get a very, very small number, which we're looking pretty good. So now let's go ahead and do your average error over here. So the different types, A sub E is equal to square root. So just SQRT. And then we're typing in SSE divided by count X, sub 1. That is just taking your X values. And now here you will have your average error. So again, does this average error fit with what we know visually? Is it a good fit, right? And then again, your correlation coefficient. Well, this being a very, very small number, right? Especially in comparison to your X or your Y values, notice that there's not a whole lot of gap. So having this small number really means that this is a great fit.